This video is going to walk us through the process we use in Pythagoras theorem to solve triangles. And it's always a right angle triangle. If we don't have a right angle triangle, we can't do Pythagoras, and we have to redraw the situation so we do have a right angle triangle. First step is always to label the triangle. Opposite the 90 degrees is the hypotenuse. The other two sides we can't label opposite and adjacent because we have no angle to work from, so we just call them A and B. Doesn't matter which one's A, doesn't matter which one's B. So there we have our triangle labeled A, B and H, where H is the long side. And Pythagoras theorem says that the hypotenuse squared is the sum of the two short sides squared. But in practice it's a lot easier to remember that H squared equals A squared plus B squared, or if we want to do it in one step, we can do the square root of A squared plus B squared, making sure that we square root all of A squared plus B squared. So let's have a go. Here's a pretty typical example. We have two sides of a triangle, 12 and 15, and we want to find the length of the long side. Whether we use the left or the right hand formula depends a little bit on what type of calculator we have. If we have the old style calculators that don't allow us to put things inside the square brackets, then I suggest the left hand side. If you have a modern calculator, then by all means go and do it using the right hand side. So we put our numbers in. 12 squared plus 15 squared is 369, and the square root of 369 is 19.21. That's all the process is for finding a long side. We'll do it again. We establish that the unknown side we want, x, is the hypotenuse. We have our formula, h squared equals a squared plus b squared. We stick in that x squared is equal to 9.3 squared plus 7.2 squared. Calculate on the calculator, 138.33, and square root it. That's all the process is, and we just have to mechanically make sure that we identify the hypotenuse before we start. However, we can also use it to find one of the short sides, because we can rewrite it as a squared equals h squared minus b squared. Now this will generate a smaller number because of the subtraction, which is right because we want a shorter side. We can also do that in one step with the subtraction inside the brackets if you have a modern calculator. So let's have a look very quickly at how we would do that. We have a triangle. First step up is to establish that the side we want is not the long side, it's the short side. So we have to rewrite our formula. Instead of h squared equals a squared plus b squared, we rewrite it to be a squared equals h squared minus b squared. Then we put the numbers in, making sure that the big number, the h, is first so that we get a positive. So 215 squared minus 150 squared, bit of a number, which we square root, and we find that the short side is 154.03. Same process one more time then. We want k. We identify that the 19.4 is the long side, the hypotenuse opposite the 90 degrees. Therefore, we have to use the rewritten version of Pythagoras theorem. Stick in the numbers, and we get our answer. So that's basically all there is to it. We have a formula, h squared equals a squared plus b squared, which we rewrite if we want a short side, so that a squared equals h squared minus b squared. Fairly simple to remember which one to use. If we want a long side, then we need to add to get a big number, because h has got to be bigger than a plus b. If we want the short side, then we use the subtraction, because a must be less than h. So we need to take away something from the h squared. After that, just care to put it in your calculator and not forget to take the square root at the end.